Have you ever looked at a race car and just thought, wow, how do they even build something that fast? Well, today we're going to pull back the curtain and find out exactly what it takes to design a super fast STEM race car. Let's get into it. Okay, just look at this thing. It's an absolute beast. How does something this awesome go from just an idea to a real-life track-shredding machine? Now, you might think of that without being a genius and getting it perfect on the very first try, but the real secret is actually something totally different. You see, every single cool invention, whether it's your phone or this race car, it all starts with a plan. You can think of it like a recipe that engineers follow to turn a brilliant idea into an actual thing you can touch. And when you boil it all down, that recipe is super simple. It really just comes down to 3 steps. First, you got to imagine it. You dream up the coolest, fastest design you can think of. Then, you build it. You make a real version of your idea. And finally, this is the best part, you test it to see what it can really do. This right here is the official name for that recipe, the design cycle. I know, it kind of looks like a secret code with all those arrows and circles, right? But it's really just a map that guides engineers through those same 3 steps. Imagine, build, and test. It's how they make incredible things happen. So you've got your plan and you start designing, but almost immediately, engineers run into this giant challenge. I like to call it the perfect world problem. Let me show you what I mean. On a computer screen, everything is perfect. The design looks smooth, flawless, ready to go. But look at the picture on the right. A real car isn't just one solid piece. It's a huge puzzle made of tons of different parts, the wheels, the body, the wings, all of it. And the first giant puzzle is just getting all of those pieces to fit together in the real world. Yeah, you'll hear engineers say this all the time, usually with a little sigh. Well, it worked in CAD. CAD is just the fancy name for the computer software they design on. And they say this when that perfectly built on the computer doesn't quite work out in real life. And that's really the heart of it, isn't it? The real world isn't perfect. No machine, no matter how amazing it is, can make a part that's 100.000% perfect every single time. There are always tiny, teeny, microscopic little differences. So what do engineers do? Well, they have to plan for these tiny imperfections, and there's a word for it, tolerancing. It's basically deciding how much wiggle room a part can have and still do its job. Think about a Lego brick. If it's just a tiny bit too big, it won't click into place. A tiny bit too small, and your whole tower gets wobbly. Tolerancing is how engineers make sure everything fits just right, even when it's not totally perfect. Now, I know talking about imperfections and mistakes kind of sounds like a bad thing, but this is where engineering gets really, really cool. Because in the world of design, these so-called mistakes are actually awesome. I'm serious. When a part doesn't quite fit or a wheel has a little wobble, that's not a failure. It's a clue. The car's basically talking to you, shouting, hey, over here, if you fix this one little thing, I can go even faster. These clues are the most valuable things an engineer can possibly find. So how do they follow these clues? Well, let's say one part is rubbing against another. That's friction, and it's slowing the car down. That's a clue to maybe reshape that part. Or what if the whole car feels wobbly? That's a clue to check how the wheels and axles fit together. Is the car just slower than the computer said it would be? That's a huge clue to look at the car's overall shape, its aerodynamics. See? Every mistake is actually a signpost that points the way to a better design. And all of this leads us to the most powerful, most exciting, and most important part of building a winning race car. It's a simple little cycle: test, tweak, and triumph. So let's go back to our design cycle map. The real magic, the secret sauce, is in that loop at the bottom. Based on results, make changes, test again. This is the engine that drives all innovation. It's not about going in a straight line. You build something, you test it, you learn from the clues, you make one little change, a tweak, and you test it again. And again, and again. This is why physical testing is your absolute superpower. Computer simulations are cool, but nothing, and I mean nothing, tells you the truth like a real-world test on a real track. The trick is to only change one thing at a time. That way you know exactly what made the difference. And you run lots of tests just to be sure, and you write down everything you learn. That's how you build a champion. And this is what you get. This incredible winning car you're looking at, that wasn't the first try. It probably wasn't the 10th try. It is the result of that amazing loop of testing, finding clues, and making smart little tweaks over and over again. Each cycle made it a little faster, a little stronger, and a little closer to perfect. So if there's one big idea to take away from all this, it's that success in engineering isn't about being perfect right from the start. It's about being brave enough to try something, see what happens, learn from it, and then have the courage to try again, only better. This process is how every great thing in the world gets built. So the next time you see some amazing new technology, remember the journey it took to get there. This whole process of trying, learning, and improving, it's how we can make anything better. So, what will you improve today?